My camera on?
Yep.
Yeah.
Good morning, everyone. We're just waiting for a few more people to log in, and then we'll get started. Okay, let's get the show on the road. Good morning, everyone. My name is Sue Davies, and I will be chairing this session for you this morning. Sorry, my cat has just climbed on top of the table, so apologies for that. Just to run through the etiquette for the session, if we can all keep ourselves on mute, and all Q&A questions will be directed via the chat function. And if we have any technical issues, then please log off, log back on again, and everything should be okay. So I will just pass over to, to Nick, who will do the intro before Mike gets going with his presentation. Thank you very much.
Thank you, Sue. And thank you very much indeed, everybody, for attending. This is our second in our series of webinars. So last grants and how to improve your chance. Tracy, who's one of the 3 mentors. That talk is available if you didn't see it then. I've had this very dangerous so I might. And next week on Wednesday at 10 o'clock, we have better business plans, how to really get under the skin of what the business plan is really for, and what the readers are really wanting to know. So the link for that will be sent out later today, and indeed I will put it in the chat if you're interested in registering. Please register for the day before. But today we have an introduction to the space industry by Mike Curtis, who is again one of the 3 mentors for the Astropreneurs program. It's a considerably difficult task to sort of summarize the space industry in 30 minutes, but we thought Mike was up to the task anyway. So I'll pass you over to Mike, and as I say, questions to up the session with a few Q&As at the end. Thank you very much, and over to you, Mike.
Thank you, Nick, and good morning, everybody. Nick, can you just give me a thumbs up that my screen's live?
Yes, you're fine.
Excellent.
Yeah, it's great.
Excellent. I might also offer an apology, similar to Sue, if my cat appears at some point, please ignore it and listen to my presentation instead, despite what my cat thinks. He is not the center of the universe. So I'm Mike Curtis. I've been around on the Harwell campus for probably now the best part of close to 20 years, working with people like Nick and Ian, and more recently like Don, in a variety of capacities. So, I mean, I thought I'd just give you a little bit of my background. So, by background, I'm an electromechanical engineer. I trained in robotics, and I've spent the last 20 years bouncing around in a whole variety of different areas. So I've worked for STFC, I worked for the Satellite Applications Catapult, I also run my own consultancy, and I do a range of things. And just a couple of areas just to highlight, just to say where I'm coming from. So I've developed, for example, propulsion systems to allow the guy in blue at the top of the screen, a guy called Andy Torbett, to jump out of a plane and do the interesting thing of fly towards the ground to try and exceed the speed of a peregrine. This was for a CBBC series. He didn't die, which was a bonus. In the middle was validation of spacesuits for both the Canadian Space Agency, German Space Agency, and a private company called Final Frontier Limited in the US, who have just been awarded a contract to manufacture lunar spacesuits for NASA. So some validation and playing at literally being astronauts. Top right was analog robotics field trials that I ran with the UK and European space agencies, and did in conjunction with STFC and other research organizations. And touching in an area where I play, and I use the word play because it's probably the best phrase, my friend Richard Browning, you might have seen flying around on jetpacks. I've done a lot of the development on the technology he's using as a jetpack. So the image there on the bottom right-hand corner is the latest generation, I think the Mark 5 we're on now, which is a more wearable, more controllable jetpack. So a little bit about who I am. I dabble in lots of areas. I know a lot about many things. I don't necessarily know a lot about things in detail, but I can generally bring capability together and identify where there's opportunity. So what is space? Well, I think this is probably one of the best ways of talking about what 21st century space is. So some of you may have seen this image before. If you haven't, then take a look at stuffinspace.com, and it is a dynamic, not quite real time, but map of the debris of objects which are in space. So what you're seeing there is the Earth at the middle, and you can see the density of debris surrounding it, but not just the density of debris. So if it's red, it's debris. If it's blue, it's a satellite. And if it's yellow, I think it remains of a launch stage or something similar to that. But there are thousands of pieces of debris there. Now, the interesting thing I always find fascinating is if we dial this back to 1950, nothing was there. All of this is a legacy of humankind's ability to put things into space successfully, unsuccessfully, and keep them there. And this in itself is a market, but this is effectively the last 70 or so years, this is what we've done as a species. We've managed to surround our planet with a whole variety of different bits of things. Some of those things are useful, many of those things are not. But where there is effectively junk, for some companies, there's also opportunity. So what is space? From a space industry perspective, we've effectively got the hardware element. So from left to right, we've got satellites, we've got the International Space Station, we've got the ground segment network, the hardware which does the job. In the middle, we've got applications, data, Earth observations, GPS, navigation, imaging, taking the capabilities of the hardware and getting it to do something for us. That's the commercial side. We've also, of course, got the science side. So looking at the sun, looking at other planets like Mars and human operations in space. That is broadly what the space industry is about. It's about hardware. It's about doing things in space from an environmental navigation and imaging and remote sensing, or ultimately it's about curiosity, looking beyond and saying, what's there? What does it mean? How does it influence us? What can I learn from it? This is the space industry. When we look at the space industry, it gets a little bit more complicated. So broadly, it splits into two halves, upstream and downstream. And this is terminology that we hear on a regular basis. You'll also hear an awful lot of acronyms. Those of us in aerospace and defense, etc., refer them as TLAs. So a three-letter acronym, and there are many of them. If I use any of them, please flag me, and I will try and pick you up. And if I don't, then please flag it as a question later. TLAs are a good way of effectively compacting complex information. But the problem is we can end up talking in TLAs all the time, which leaves an audience which isn't necessarily specialist a bit bewildered. However, upstream and downstream are probably two of the big terms. They're not TLAs. They're definitions in terms of capability. And they are more or less exactly what they say. So downstream space is about taking the data from spacecraft. So this might be GPS, so guidance navigation, space systems, Earth observations, looking at pollution, monitoring methane appearances, looking for CO2, looking at ice cracking, etc. meteorology, so weather, and something which is probably one of the most critical functions, but is often frequently overlooked, taken for granted now really for the last 60 years. And finally, something that right now we're all using simultaneously is communications. So almost certainly 90% of what I'm talking about right now and the medium I'm using is in some way going over some form of bearer, etc. So that's downstream. Then, of course, conversely, we have upstream. So upstream is launch vehicles, satellites, ground-based networks for communication and manufacturing, the things we need to do to get the stuff which does things to do things. And the two you have to have together. You can't have one on their own. I mean, you can, but arguably no one's going to launch vehicles if they don't do anything. And at the same time, you can't, as people occasionally say, well, we invest too much in space, but then complain that their GPS doesn't work. You can't have good GPS if you don't have a satellite network. So the two go hand in hand. However, there was also effectively a third now. So we're now beginning to see something referred to as midstream space. And this can be effectively generalized as operations in orbit, which is using capability and using applications and using data. The most recent illustration of this probably was the Northrop Grumman mission extension vehicle, which docked with a defunct comm satellite and raised it to a higher orbit, bringing that satellite back to life. That was combining a combination of hardware, localization, identification, and something which is really becoming very key in space is autonomy and robotics. So using machine learning and AI to identify where that spacecraft was, docking and connecting with it. So that's effectively the three areas: downstream, midstream, upstream. From a space agency perspective, we're seeing a pretty rapid growth. I mean, in the last 10 years, we've seen a lot of space agencies, including in the UK, the United Kingdom Space Agency, pop up. So there's a whole variety there. It's not just about NASA. It's not just about Roscosmos and a Russia perspective. It's not just about DLR from Germany or JAXA from Japan, CNES from France, etc., etc. There's an awful lot of space agencies there. And of course, in the middle in there is basically ESA, which is a space agency which represents multiple countries. And that's something unique because we don't yet see effectively an African space agency. We see an aspiration toward it. We don't really see a North American space agency. And consequently, within ESA, we have countries like Canada. So effectively, they are a partner nation by extension, but they actually bring a lot more to ESA by being in there. So ESA is actually a very unique and very democratic space agency. And actually, one of the mandates of what ESA is ESA doesn't do defense. And while it has companies involved in it, unsurprisingly, who have defense activities, ESA is a peaceful space agency. Its mantra is, and its mission is to support the peaceful exploration of space for humanity and the commercial benefits that bring. NASA, however, are fundamentally different. NASA is about supporting the aims and the aspirations of the USA. Yes, that's about science, but it's also about defense. So here we see basically a stack of the national space agencies and their respective budgets. How do they stack up? How do they compare? Europe, we don't do badly, and these budgets are roughly out slightly. So currently the European Space Agency budget is closer to 7 billion. That's in dollars, but you can still see that's almost basically just a third of the USA space budget. And then you see effectively that fairly high domination in terms of space coming from some of the other European nations as well. France and Germany, Italy, etc., all invest significant amounts of their annual GDP into the space program. You can see the UK, for example, our space budget is tiny fractionally, 0.41 billion. Really nothing to really write home about. But surprisingly, actually, when you look at the Canadian space budget, which is at 0.49, if you think what Canada does for its space budget versus what we do, it's very different. The UK has different priorities. Canada is much more interested in space exploration. It has an astronaut corps of 12 astronauts, and it has significant expertise in building complex robotics and systems. So all the robotics arms on the space station, for example, are built by Canada. The original robotic arm on the space shuttle was also built by Canada. I suspect, though, this global budget, 43.4 billion, is probably going to realistically double in the next 5 years, because not only is commercial space becoming a key factor, we're also beginning to see greater investment, in fact, in activities like return to the moon, etc., and not just by nations in terms of the US, India, China, Russia to an extent. Other nations like Brazil, United Arab Emirates, etc., are beginning to express an interest in doing so. And realistically, you can't get to the moon for anything shy of $1 billion, any more than you can basically build a launch company for anything shy of about $250 million. So I stole this slide from the BBC, and I have absolutely no shame in doing so. There's old space and new space, more terminology, and this is probably the simplest way of describing it. So I mean, you can all read this clearly. I will read it for context, but forgetting the old rules of space, now anyone with enough money and enterprise can get there. This race isn't between countries, it's between companies. And this is effectively the big transition. So 10 years ago, if you look at the launch vehicle market, there were probably no more than about 10 launch vehicle companies. And when I say launch vehicle companies, I mean people like United Launch Alliance, Ariane Space, Roscosmos, one or two others, SpaceX beginning to rear its head. Today, there are 248 companies globally trying to build launch vehicles of some flavor. Almost half of them, at least half of them will fail because they are slideware, not hardware. They have no experience in building rockets, they don't understand the technology, etc. But 248 companies, can you imagine that? The growth of that number of companies across the world who want to build launch vehicles is practically there are companies in almost every nation. So we're seeing launch vehicle companies coming out of countries like the Philippines, out of Brazil, out of Bolivia, out of Georgia, and even think Fiji have got an activity going now. Many of these are going to fail, but basically it says, if you've got money, or you can raise money, or you can convince someone else ultimately to part with your money, and there are people here like Ian Tracy and Don in terms of mentors who can certainly help you on the journey of persuading other people to part with their money to help you get there, and you've got the enterprise, then the reality is you two can compete. So that is old space. Old space is NASA, old space is the ISS, old space is the space shuttle, old space is USA versus Russia. New space is, it's about you guys and anyone else basically in between who has basically enough metal and enough balls to say, I want to compete, I see an opportunity. So what's the market look like? Who's playing in this market? Well, unsurprisingly, as you can imagine, it's pretty big and it's growing. So again, I've stolen slides from Seraphin because Seraphin are great. If you don't know Seraphin, they're worth being aware of from a funding perspective, but they basically generate market intelligence, and they're also a private venture company supporting the space industry within Europe. So launches, no surprises there. You've got the ubiquitous SpaceX, Virgin Orbit, Blue Origin, Vector, Orbex in the UK, Virgin Galactic going off in their space tourism direction. Will it ever survive? PLD Aerospace based in Portugal, Firefly and Skyora, who are actually both the same company technically, both owned by New Space Ventures. Spin Launch, I think are completely crazy, but they might see them succeed. They're building a giant catapult in California, which is going to literally catapult things into space. No association with the satellite applications catapult, though sometimes I think we wish we would. Launch services, you've got companies like NanoRacks and Spaceflight providing access to space capabilities. And then you've got a whole variety of other people dabbling in other areas which are aligned to launchers, but aren't necessarily launchers in terms of high altitude platforms, drone tech and things like that. From a hardware perspective, we've got people like GomSpace, we've got Clyde Space, we've got Spire, we've got ThrustMe, Open Cosmos, etc., building small satellites, building capability, building solar panels, building navigation arrays, building compute, etc. Robotics, people like eVince Technology doing state-of-the-art diamond manufacturing substrates to replace silicon for better performance. Bright Ascension doing operations from a perspective of onboard compute operations. Carbon 3D, Oxford Nanosystems, Carbon Ice, etc., developing specific materials, etc. So there's a big space there. And satellites is only bigger. So you've got ICEYE, you've got Spire, you've got SatLogic, Axel Space, etc., doing Earth observation. OneWeb, will they survive Chapter 11 administration? Who knows in the telecom side. Internet of Things network, companies like Astrocast and Kepler delivering capability. Plenty of people doing stuff in drones. Satellites, there's a whole variety of people in there. Some of you've heard of, I'm sure, Space Now, Bird Eye, Cloudo, GSI, etc. And the relay systems, communications and data storage, lots of people playing in these spaces. And enabling all of these in the background, you've got companies like Lockheed, you've got Northrop, you've got BAE Systems, Leonardo, Thales Alenia Space, the conventional big aerospace companies. Lots of them there, but they form this big ecosystem. And on top of that, we've got basically, this is downstream space, so the things coming from spacecraft. So Indigo and FarmLogs, Mapbox, VHive, Teralytics and Geospark are all basically platforms which are pulling data from spacecraft and doing something meaningful with it. And they're the products, but you've also got platforms which are kind of in a hybrid model. We've got ESA's extremely successful Copernicus program of 6 satellites, 4 flying, 2 to fly, which generate abundant data on a whole variety of different metrics for the Earth, and provide that data freely to anyone who wants it. Doesn't matter where you're in the world, broadly what you're doing, you can utilize that data. You can sign up and access it. So for those of you who are looking to offer products, who are looking to utilize data, etc., the Copernicus program is, there was nothing like it 20 years ago. And the quality and the fidelity of the granularity of the data which comes from those satellites is phenomenal. So it's worth looking at. Global market size, well, as I said, it's getting bigger. This gives you a kind of idea of market share and where countries are aspiring to go. So the global market size currently is about 250 billion, maybe creeping up to 300 billion this year. Metrics change constantly, as you can imagine. By 2030, the anticipation is that the global space market is going to be about 400 billion. I think that's probably out, not by an order of magnitude yet, but I suspect by 2050, we could be out by an order of magnitude. Certainly, I think by 2030, the global space market is going to be worth closer to 600 billion and 400. And the UK, for example, our market share was about 9 billion in 2010. It's now closer to 14 billion, 15 billion. By 2030, it realistically could be easily 40 billion or therefore bigger. A good document if you want to look at growth and you want to look at numbers is the UK Space and Innovation Growth Strategy. There's a lot of hard data in there. Just remember, most data doesn't survive the moment you present it. So everything here is almost out of date the moment I tell you that. So there will always be opportunities for more, and you will see some sectors growing while we will see other sectors contracting. So how does a private space market look? Well, roughly with a value of about $300 billion per year. Or moving roughly in that direction anyway. It's split into a variety of areas. So some of those big areas are, unsurprising, satellite launch takes up about 13% of it. Manufacturing is another 20% thereabouts. Earth observation, satellite internet. They form the kind of the backbone of what are we doing in space, who's paying to do things in space. Manufacturing is fundamentally in underpinning those areas, but it's about launch, it's about satellite internet communications and Earth observation. And then you've got other things falling out of that. Lunar landing, beginning to pick up, seeing about 5% activity there. Space research, always broadly in the background. Deep space exploration, looking at other opportunities out there. Asteroid mining, space tourism, dubious about how viable they actually are, but still occupying a few percent. And finally, space debris getting bigger. And companies recently, like, for example, relatively recently, like Astroscale, who are UK, Singapore, I'm not entirely sure we can call them a startup, but they're still an SME. They've raised something in the vicinity of 140 million to remove debris in defunct spacecraft. Now, they're not just removing defunct spacecraft, they're basically doing mission extension life to platforms in space. So a little bit like Northrop's mission extension vehicle. They're not really going to remove all the rubbish from space, because if you imagine my first slide showing all that debris, it's next to impossible to achieve that, but certainly reduce it. So what are today's challenges? Well, there are many of them, and I've tried to capture a few here. So one of them, for example, is solar power. We need more power on orbit for our spacecraft, for our robotics to do things. So higher efficiency solar panels, more compact, give us more power and more capability. And thermal management's wrapped up in there. Radiation protection is an ongoing pain for anything in orbit. The further you go, and if you certainly go outside the Van Allen belts, you lose that element of protection of your spacecraft from a radiation perspective, and your electronics are exposed to hard radiations. So that's a critical area. New materials, new processes, new approaches. Low cost launch, well, 248 companies trying to build rockets. To be honest, there's probably room for more, because as I said, at least half of those won't survive. Virgin Orbit's slight mishap 2 weeks ago when they did their air launch from the Mojave Desert, and their launch vehicle exploded 9 seconds after being dropped. That's nothing new. If you're in the space industry, most people watch rocket launches, irrespective of how many they've seen, with the vague expectation of, is it going to explode? And we will generally pray it won't, but there is always that risk. High resolution synthetic aperture radar. How do we basically do high resolution Earth observation and Earth imaging with a more compact product which we can deploy on smaller spacecraft? Big question, lots of companies looking at it. Most recent innovations are coming out of companies offering SAR-based systems the size of a small suitcase. People want to go smaller, they want to do more with it. Mass manufacturing underpinning everything, launch vehicles, spacecraft, on-orbit manufacturing, etc. How do we scale up and build spacecraft faster? No one's really yet come up with a solution. When you're building launch vehicles, there's only 3 ways to basically make launch cost effective. Build big, i.e. the US SLS system, build many, equivalent to basically building many fridges or building many missiles, as various countries have done, or build reusable, as various space companies are doing. But mass manufacturing is still an underpinning tenet of all of that. Space debris I've touched on already. It's a factor, it's going to get worse, we have to do something about it. People are beginning to try and do things about it, but a lot of people often conjecture that you can just basically fly around in space going from point to point, collecting the rubbish and recycling it. Stuff in space is not recyclable right now. Most of it's been there for 10 or 20 years, and it's a combination of aluminum, ceramics, alloys, plastics, and things like that. It would be like going to the bin in your local park, scurrying around inside the bin and hoping basically to be able to find enough raw material to be able to build a sports car. You're not going to build a sports car with the contents of the local bin in your local park. It's just not going to happen. And any more than you're not going to be able to build a spacecraft or a space hab or anything like that by collecting a large quantity of the junk floating around in space. You also have to get to it. And the distances there, as many of you are probably conscious of, are vast. Space tourism continues to be one of those areas where people get excited by. Is it really a market? Who knows? We're going to see that over the next couple of years as companies like Virgin Orbit, SpaceX, Dream Chaser and others try and take people, and some of them will almost certainly fail. So we'll see our first catalogue of probably some fairly serious space fatalities on space tourism flights. They're going to try and take people into low Earth orbit, potentially to the space station. NASA's now said that they're willing to host basically people for up to 10 or 11 days at a mere $27,000 per night on the space station, which is comparatively cheap. I think you can pay more for a villa in the Maldives. However, of course, the challenge for the space station is it's all very well to book yourself a place, but it's not as if you can just call your local Uber and get a quick flight there. So getting there is part of the challenge as much as anything else. And finally, and not unreasonably, constellations. More satellites. I've stayed away from constellations to an extent in this presentation because there is so much rhetoric about it and it's very hard to work out what's going on. Starlink coming from SpaceX is probably the most active constellation, but it's, to an extent, it's questionable exactly what Starlink is doing, or is Elon Musk literally just trying to get all the slots he's been allocated filled and then he's going to do something? As many of you know, trying to work out what on earth SpaceX and other companies belonging to Musk are actually doing is pretty challenging. But there are other companies out there, Planet, for example, with their small Earth observation constellation, Thales with their Blacklink constellation, OneWeb with their slightly ill-fated constellation. Will it survive? We don't know. So lots of opportunity there. So what about tomorrow's science? Well, this is NASA's map for the exploration of Mars. It's based on technology, exploration, and science. But this is tomorrow's science. It started with activities like the Hubble. It's moved on to the International Space Station, underpinned by the Space Launch System, which helps facilitate orbiters and landers. It's about moving to commercial cargo and crew, as demonstrated by the Dragon crew launch a couple of weeks ago. Orion, which is effectively returned to the moon via Artemis and other platforms. The Gateway Station, which is the next space station being built currently by Lockheed and Northrop, which will be in orbit of the moon, but is a movable space station. So it's about those technologies. And yes, absolutely, there's opportunity here, but this is very much about science-driven curiosity. This is about exploring our solar system for the sake of science. It's not about exploring our solar system to make you wealthy. It's not about exploring the solar system for space tourism. And it's not certainly about manufacturing new materials, new products, and new services. It's about science. So what's tomorrow's industry? Well, tomorrow's industry can be more represented by looking at the slide on the right-hand side, which describes itself excitingly as the broad cislunar econosphere. And this is much more industry-driven. So this is about, you've got the ISS in there, absolutely. But this is about manufacturing products on orbit, making fiber optic cables, which have a performance 100 times better than those you can manufacture on Earth, making new types of pharmaceutics, which have a higher yield at treating cancer than anything we can make in a terrestrial environment. Solar power stations in geostationary orbit, beaming power back to Earth to reduce our carbon footprint to zero, yet effectively doing that and providing sufficient energy so our hungry economies and societies and industrial bases can continue to grow. Communication satellites, not only providing those comms for the Earth, but also providing communications across the deep space network, going to the moon and beyond, which in turn facilitates the abilities for private space stations, which allow us to do things like asteroid prospecting, identifying where there's minerals of interest, which we can either go to and do in situ resource extraction, or as some people propose, bringing those asteroids back to the Earth. And you can imagine that various people are somewhat dubious about that. And then potentially activities like lunar prospecting, lunar mining, and beyond. So all of these activities involve robotics and automation, material science and production, propulsion system, chemical, electric, hybrid, net shape manufacture, the colloquial term for additive manufacturing, which is the colloquial term for 3D printing, massive data handling, and extended Earth to deep space networks. So there's communications in there, there's services, there's manufacturing, there's legal services in there, so there's finance, there's a whole series of other secondary activities which have to happen if those activities are happening in the first place. So just briefly touching on a little bit on funding, etc., because it's all very well to do these things, but how do you do these things if you've got the enterprise but you don't necessarily have the cash? There's a variety of networks in the UK and within Europe. Innovate in the UK, for example, run our funding competitions, and some of these are coming to an end, but they're still available. There's funding coming for robotics and AI via the Fair Space Hub at Surrey Space Centre. There's a space technology infrastructure system, which has got another 100 million or so in there. The UK National Space Technology Programme and the General Space Technology Programmes both have money. As you can imagine, ESA does under its GSTP, which is orchestrated by the UK Space Agency or equivalent country-based space agencies in their respective regions. And Horizon 2020 indirectly, clearly funding Astropreneurs, but funds other activities as well. So big funds, lots of activity there from a public perspective. I touched on Seraphim earlier. Seraphin's the world's first ventures fund dedicated to the space sector. They've invested over 70 million over the last 5 years into key investment portfolio projects like Spire and ICEYE and Myriad, etc., quite successfully growing. And they also provide a very high level of good, high quality market information. So looking at their information, my earlier slides talking about hardware, launchers, satellites, etc., is derived very much from the research that Seraphim do. And Seraphim in turn works with organizations like STFC, like the Satellite Applications Catapult, and many others to ensure that they get the right data, the meaningful data, and the appropriate data so they can advise their investors, but they can also advise companies who are aspiring to basically be funded and join their respective space camps. So well worth taking a look. And if they're not necessarily a company who are going to support you today, they may well be a company who may support you tomorrow. So I'm going to basically conclude there. I would just echo that space is hard, but that's why we try. Personally, I think the market is big, and I think it's getting bigger. I think areas like launch vehicles are a little bit oversold, and you really have to be doing something quite new and quite novel if you want to actively compete there. But satellites, data networks, exploitation of manufacturing systems in space, communications, and the wider terrestrial benefits is a market which is just continuing to grow. I will stop there and take any questions. Thank you.
Thank you very much, Mike. Sue, would you like to pick up on any questions asked?
Yes, we have a few questions. The first question, do companies like NASA and ESA buy from or engage with SMEs, or do they go for the prime contractors only?
Absolutely. So NASA is always engaged with the SME base. It's always been slightly trickier if you're outside of the US, but they have programs, and they recently launched another call for enabling technologies. So they are always interested. I mean, it's harder to do business with the US, but it's not impossible. And in the UK, certainly, the Department of International Trade, etc., will help support and facilitate those interactions, as will agencies like the UK Space Agency, Innovate, and indeed many of the people sitting virtually in this room. For ESA, again, yes, absolutely, they have an aspiration to support the SME base, and they launch a whole variety of calls. The one challenge I would say with ESA is that their proposal system, which if you're going after specific areas of technologies, is quite difficult. It's called EMITS, and it's worth having someone who can help you and guide you through that journey, because fundamentally it's somewhat complex. But yes, they also have their General Space Technology Program, which is a more open-ended call, which allows you to pitch your bid for funding for a variety of thematic activities.
Thank you. Does the UK involvement entirely depend on government investment, i.e. ESA or the UK Space Agency, as opposed to private investment? Presumably this will depend on whether the UK government wants to continue to support the growth.
Well, I mean, so I don't fully understand the question in terms of is that with respect to activities that the UK sponsors in space, or is that activities in space overall? Let me answer it from both perspectives. From a UK Space Agency perspective, well, absolutely. Government doesn't provide the funding to support specific activities, then the Space Agency won't do it. And conversely, the Space Agency won't bid into ESA to do those activities. On the flip side, there's plenty of commercial activities which you can do without the Space Agency. Our Space Agency is there to provide advice, regulation, and expertise to an extent, not necessarily funding per se, as NASA awards hundreds of billions to do a whole variety of different things. So yes, government spend does impact to an extent, but it shouldn't be a barrier either.
Thank you. Can you tell us what the UK space priorities are, and ESA's? You mentioned Canada's, where robotics and astronauts.
So there are various. ESA's priorities is continuing to deploy the remainder of the Copernicus program, the exploration of Mars through ExoMars and subsequent rovers, particularly the Fetch rover, which is now being designed, which will jointly with the US return Martian samples of regolith back to the Earth. Communications, meteorology, maintaining the European GPS networks, Galileo, etc. Those are all key for Europe. From a UK perspective, we're trying to build and establish, as many of you are familiar with, our spaceports and our basic industrial base, supporting those, some of our small launch vehicle companies like Orbex, Lockheed Martin's activities to start running launch operations, and something they call an orbital maneuvering vehicle, which is basically a spacecraft which carries smaller spacecraft. Our space agency very much focusing on regulation, getting companies to operate in the UK, come to the UK and do business in the UK.
Thank you. Is space mining really a viable opportunity?
Yes and no. A little bit like having a hotel stay on a space station. It's a great opportunity, but you have to get there. And if you can't get there, you can't have it. So yes, and the first people to get there, there's a couple of companies, Deep Space Industries, Daniel Faber, operating out of California. He's an ex-NASA scientist. He's raised about $45–50 million. They've built a spacecraft which is heading to currently rendezvous with a potential asteroid, which I think is made something like 55% of iron, 30% of aluminium, and about 10% of water. And that's ideal, because there is this kind of a fairy tale of going and finding asteroids made of diamond and gold. I mean, you could absolutely do that, and they almost certainly exist. But if you bring an asteroid which weighs 1 trillion tons of gold into proximity to the Earth, I mean, apart from the fact it's a little bit risky, you'd completely and utterly destroy the UK's economy. If you make gold as common as Earth, gold's no longer valuable. I mean, and gold's notionally useful, but there's only so much gold you can use. So The materials people are interested in are those like aluminiums, steels, titaniums, which you can use for in space construction, and more importantly, ice, because ice is probably one of the biggest commodities. So deep space asteroid mining isn't necessarily about metal. It is much about organics and things like ice as well, because from ice I can make rocket fuel, I can make oxygen, and I can basically make water.
Okay, very interesting. And the last question is, which top 3 areas do you think need innovation or offer opportunities for new space companies?
I would say machine learning and AI, massive, because that underpins all orbital operations. And increasingly, as we go further away from the Earth and do more complex operations, it's increasingly difficult to try and do that with humans in the loop. Astronauts and several will probably try and shoot me for saying this, are basically highly glorified space monkeys, which are paid about $18,000 an hour. They're great, but they're super curious. And if you give them interesting, shiny things, which is basically the ISS is full of, they prod them until things fall off, and then they lose bits, which end up floating around to hit the space station at a later date. So that's great. But if you want to actually build big, complex objects, you need to take the space monkeys out the loop and basically do this with robotics and autonomy. So that's one area. Second area, I would say, is about Earth observation, high resolution imaging, things like synthetic aperture radar. How do we do more detailed observations of our planet, particularly with the interest and perhaps the mass transition, this pivot point about actually beginning to care about the health of our planet. People argue frequently of why do we go into space, it's bad for the planet. Well, actually, we need to go into space to understand the health of the planet. Unless we have that barometer, how on earth do we know how well we're doing? Because we certainly can't do it by just looking around us. Climate change is going to be a big driver for Earth observation. I think the last area is probably going to fall actually in terms of skills and people. We don't have enough skilled people. We don't have the right people in the sector. There is a big piece in terms of training and STEM and outreach and trying to engage the next generation to engage in these sectors, but also upskill and reskill people in different sectors who have abilities. So it's often overlooked, but if we don't have that skill base, we won't be participating in the sector for long.
Thank you. That's all our questions. So I'll hand over to Nick.
Thank you, Sue. Thank you, Mike. I did have a follow-on question actually for the asteroid mining. I always assumed that asteroid mining was to bring the asteroids back to Earth, but is that not the case? You mine them out there and use them out there? Because I wondered when you said, why are we bringing a big lot of iron back to Earth when presumably we've got sufficient of our own?
Well, we do, and the reason to go to asteroids is to either carve them out and make interesting things like Dyson spheres and O'Neill habitats and things like that, glorified, exciting things that anyone here who was small in the last century probably remember, and that's never really happened, so we're all quite sad about that. The problem about bringing asteroids back to Earth is twofold. One, well, they are fundamentally massive. So it's not so much as bringing them back to Earth. You can't really go and tractor them back. I mean, you could hypothetically, but we don't have the ability to do that. You're going to basically deflect or correct the orbit. Now, we have objects passing the Earth on a regular basis, and they fortunately pass the Earth and smaller ones burn up. But if you decided to seriously alter the trajectory of an asteroid, and the only way really to do it is with probably small nuclear charges, there's a really unfortunate risk that, I mean, it's a tiny risk, but it's an unfortunate risk that we could go the same way with the dinosaurs. So we could basically see massive commercial gain for all of effectively 55 days or 2 years, and then promptly lose the entire continent of Europe, which probably most underwriters would be pretty unhappy about.
Yeah, I guess so. Yeah, okay. All right. Well, look, thank you very, very much. I think that was an excellent talk, quite brilliant, really. It was sort of to infinity and beyond in 30 minutes, which I think was a pretty good achievement. So thank you, Mike. To everybody else on the call, thank you for coming and attending. A recording will be available, and if you contact Mike, he can engage with his slides as well. As those of you in the UK program of Astropreneurs, Mike is one of the 3 mentors that will be helping you. And so shortly over the next sort of week or 2 weeks, we'll be in contact and having one-to-ones. Once again, thank you very much, Mike. Just to remind you that there is another tutorial webinar, mentoring webinar next week on Wednesday. I think it's at 10 o'clock. And this is the Better Business Plans. It's not just a sort of what is a business plan, what are the chapter headings. It's really trying to get under the skin of why, you know, a good business plan and what the readers, the investors will be actually interested in reading or understanding about your project. So we hope that it's a separate sort of second order differential in terms of depth for your, you know, a business plan. So please attend if you can. The link was in the chat room, and I'll send the link out to your email addresses later on today. Anyway, thank you very, very much, everybody. Thank you again, Mike, and look forward to seeing you next week. Cheerio.
Thank you very much.